everyone, and welcome to this live workshop where we are going to be ditching the single color LEDs and instead upgrading to a whole strip. It kind of knows how projects go in here, and it was trying to make its last ditch attempt at escaping. But oh no, by the end of this, I'm going to have you wired. We are going to go through some first basic animations that you're going to be able to use as is or even modify to fit your projects. This strip is an individually addressable LED strip, which means you can individually control every little pixel on the strip. Each little pixel has 3 LEDs in it, a red, a blue, and a green. Now, to connect to an Arduino, what I normally do is cut it off. And here is my version with it cut off. It's got 3 main lines and then a duplicate of the ground and the power. So we're just going to put those away and focus on the 3. Now, there are some 4-wired ones, but I highly recommend the 3. Really easy to connect. This particular chipset is the WS2812B. We have our white ground. Our data line, this is what connects to the Arduino, and it's going to receive information from the Arduino. And the red here, and that's our power, of course. Now, in hooking this up to your Arduino, it is super important because both ends kind of look the same. So you want to look for this little arrow, and that's the direction that the data is going to travel. So you want to make sure you connect this end to the Arduino, which is going to send the data. If you connect it the other way, there's going to be a jam up. Should you get the 5 volt or should you get the 12 volt? The 5 is the easiest to power. And many of you are like, ooh, we can power it off the Arduino. No, don't power it off the Arduino. Now, the 12s, really the advantage there is that you can do longer runs without so much voltage drop. What kind of power supply do you use for LED strips? You can certainly use batteries. And if you are using the 5 volt variety, that makes battery operated a whole bunch simpler. I actually like just using a wall adapter. I have it set on 5 volts because that's what I'm powering. If you have a 12 volt strip, you can just crank this up to 12 volts. I have this nice little quick connector, which is great for sticking bare wire in it. All you do is just squeeze and it opens up the contact and you poke it in just like that. And it's pretty secure. It's not something that I would use permanently to smooth out any type of spikes that happen with the voltage. Capacitors have polarity, so that is the negative side and the positive side, and make sure you match it up. And so I have a negative and positive wire, and let's see if we can connect it to the strip. We have power, powering the strip. We have ground for the strip, and then we have a common ground that unites the power supply strip and Arduino. We need to get our resistor on the data line. And this is a 470 ohm resistor. I'm getting creative here. Clamp this together so we have our resistor protecting our data line from any data spikes. I'm going to connect this into pin number 4. So if we can all remember pin number 4, when you plug in your Arduino and your strip for the very first time, don't be alarmed if it doesn't light up. It's not supposed to. It's getting power. That data line is getting no program. You didn't write a program for it, so it doesn't know what to do. Time to code some animations. There are so many different Arduino libraries that you can use to help program LED strips. I personally like the FastLED library, so that's the one that we're going to use. In order to install the FastLED library, you can go to Sketch and include library. Now, this is not going to be included by default in your Arduino IDE. You just go under Manage Libraries, start typing in FastLED. See this very first result, the FastLED library, I have it installed. So let's include it. And that is the very first step. After we've included our FastLED library, how many pixels are we working with here? Let's define the number of LEDs. So num LEDs, how many do we have? 20. Next, we need to define is what pin on the Arduino is that LED strip connected to. So the LED pin is pin number 4. I think that's what it was. So next, we need to create an array. You might have different sections of the LED strip that you want to animate differently. You may have many LED strips. So we need to give these things their own unique names. I'm going to be super creative and call ours LEDs. And it needs to know a bit of information. How many pixels are in this array? You can put a hard number like 20 because that's what it is. Well, since we defined it up top as num LEDs, I rather do it this way. In the setup where the code runs one time, we can set up a couple additional things that the library needs to make this strip work. First bit of information, what is the chipset? So ours is the WS2812B, and you can see it's green. It's like, I know exactly which one you're talking about, which LED pin it's connected to. We only have one, so the LED pin. What is the color order of the LEDs inside each pixel? For this particular chipset, the order goes green, red, blue. We're going to close that whole statement. And now, what array does this information pertain to? It's going to pertain to our LEDs array. And how many LEDs is in our LEDs, even though we keep telling it several times? Let's set a brightness from the get-go. And I'm going to set mine to 50. This takes any number from 0 to 255. Now for the loop, this is where the fun action happens. Let's start animating something. Well, first, no. Let's find out if my color order is correct. We want to light up the LEDs array. So which pixel do we want to light up? I want to light up pixel 0. With arrays, that very first pixel is actually pixel 0. It's not pixel 1. I want to light him up red. And what I'm using here is a predefined color. If you go to the FastLED reference here, you can see information about how to set colors. And there are numerous ways, but if you keep scrolling to the bottom, keep going, oh, you hit some color blocks. All these colors are predefined that you can choose from to animate your strip with. So I'm still scrolling and there's quite a few of them here for you to choose from. Here is pixel number 2, which is actually number 1 in the array. So let's turn this one green. Let's turn that one blue. We told each pixel what color we want them to shine, but we never said, okay, now shine, glow. And the command for that is FastLED.show. Red, green, and blue. That means we set our color order correctly. Why don't we blink that very first pixel, our very first animation? We are going to turn this red, then we're going to show the red. How long do we want it to be red for? And I'm going to use delays for this. So this pauses the program. So it's going to show the red for 250 milliseconds, and then we want to turn it off. We're going to take that very same little first pixel. And how do we turn it off? Well, using the predefined colors, it's just black. And then we are going to show the black. And we are also going to keep it off for 250 milliseconds. Then it will loop back up to the top and start the code again. So this should give us a little blinky effect. Let's see if it does. You can see our very first LED here blinking. It's not very exciting. Why don't we try and move him along the strip and then move him back like a Cylon or Knight Rider? You're going to see for loops a lot with LED strip lighting because it's a great way to do a repetitive thing many times with minimum lines of code. So the repetitive thing is just moving it to different positions. For loops take a couple parameters. We need a starting position. Normally, we like to set all of our variables up here. I figured we'd do something a little bit different today and declare it right as we need it. So pixel position, and we're going to start it at position 0. What is the condition that it must meet in order for this repetition to happen? So long as the pixel position is less than the number of LEDs, then what do we want to happen? We want pixel position to increase by 1. I made up the name pixel position, but because I know you guys are going to be looking at code online, instead of pixel position, what you're probably going to see the most is the letter I. Anytime you want to do a quick iteration, writing code is about keeping things as short as possible. So oftentimes you'll see just single letter variables, the most common ones being I, K, and L. L is like extra evil. If you look at it, does it not look like a 1? Have fun troubleshooting that. That is just evil. Don't use the L. After we're out of this function, I can be reused for something else. So it's one of the advantages of declaring it locally versus globally up here. So how do we then show the light? We do LEDs, our array, and here we were putting a number, but now we're putting I, because I is going to just change every time we loop around this. And what color do we want to do? I'm going to stick with red because it is like so Cylon and Night Rider. Now that we've specified the color, show me that color. And then turn it black. So the only thing we didn't specify is how long do we want this pixel to remain? We'll do 50 milliseconds to remain lit. This pixel has traveled all the way to the end. Why don't we make it travel back to the beginning? We're just going to reverse here what we did, and we are going to set up another variable integer, because once this is out of this no longer exists. It could be reused for something else. So let's reuse it for kind of the same thing. And now we're going to start it where? We're going to start it at the top. But we have to remember that numLEDs is 20. We don't have a position 20. We have a position 19. So I'm going to go numLEDs -1, which will give us the 19. So long as the position is greater or equal to 0, then what do we want to do? We want to subtract. Subtract those positions. And here we're going to take our LEDs array and we are going to color it red. And we are going to show it. And at the same rate, like you can have it go up one speed and then fast down another speed. The LED in this statement here is going to go from position 0 to position 19. Then here it's going to go from position 19 back to position 0, and then keep repeating the whole thing until we just turn it off. Everybody, give it side-eye grimaces at this code. Oh, here, instead of a comma, it's got to be a semicolon. That thing's moving. So this is at 50 milliseconds. Instead of turning the LED off, why don't we keep it on? Let's move this a little faster. At 50. Every 50 milliseconds, it's going to move up the strip. But the preceding lights are not going to be turned off. So it's going to leave a tail of red until it gets to position 19. And why don't we say when it comes back down, it colors a different color? Let's do something that really stands out, green. So it's now going to start at position 19, work its way to position 0, coloring it green, and we're not going to turn off the ones that move along, covering the red LEDs with green now. I see this in my head. So now let's send another color. Let's do blue. What we've done is red, green, blue. Now let's send it back down. Maybe we'll do a yellow. All right, red, green, blue, yellow. Yes, guys. But what if you just want to light the strip a color? FastLED also has another cool function, and it's called Fill Solid. First bit of information that it needs is what array are we filling solid? Well, that's the LEDs array. And how many pixels do we want to fill solid in that array? All of them. And what color do we want to light it? So CRGB, can't talk and write CRGB at the same time. Why don't we fill it red like that? And then show me my red-filled delicious LED strip. And how long do we want to show it for? We can show it for like a second. Let's fill the whole thing with another color. Aqua looks kind of neat. We can pretty much just copy and paste. And then finally, let's pick a third one, yellow. We're cycling through the solid colors that we picked from red to aqua, and then yellow, and then back. The fill solids are nice. It's a great way to get bright, bold color. But what if you want something more nuanced, like a gradient of colors? There is a function for that as well. And it's called fill gradient. Very tricky there. But the only thing is you have to add this RGB at the end. Similarly to the fill solid, what array do you want to affect? LEDs, number of LEDs in that array that you want to work with. And let's start picking some colors. Now, the interesting thing about this function is that you can pick 2 colors, 4 colors, but do not pick 3. There's a weird little bug. It freaks out. It freezes. Let's fade from magenta to yellow. And let's have it show for one second. I'm going to go ahead and just copy and paste this. Make our life easy. Or not. That's when all the problems start happening, is when you start copying and pasting. So let's try and add 4 here. 4 is a little much for 20 pixels. Something like real different than yellow, maybe like red and then blue. That'll show up like a nice contrast. These are 2 colors and then the 4 colors. You know what? I stand corrected. The 4 colors do look nice on this strip. So you can experiment and you can see how nicely one color blends into the other color. There is a fill rainbow. Fill rainbow. And the syntax is very much similar to what we've been using. The name of the array, the number of LEDs in that array, and now the starting color. This specific function does not take that. It takes instead a hue color, a hue number. And for that, we're going to go back to our pixel reference. We have this cool little hue chart here. And if you look closely, 0 corresponds to red. And it goes all the way up to 255. Well, rainbows traditionally start with red. So why don't we start with number 0? We're going to make it 0. Then what's the color change delta? Like, how do you want this color to change or progress through the rainbow for your strip? We want to fit the whole rainbow. So how can we accomplish this? Well, we know that there are 255 hue values. So why don't we divide that by our num LEDs? We have 20 pixels. So divide that 255 over our strip. We have red. It goes through the colors of the rainbow and ends in our violet right before it would cycle back to red. We gotta animate these rainbows because, you guys have been so awesome. Because we are working with numerical values, just like we did for the for loop, we can now iterate through these values, unlike the predefined colors. Why don't we change the starting hue every so often? So then the colors will keep adding and adding and adding. And then colors that get to violet will cycle back to red and start it again. Why don't we make a variable here, like the start hue? Maybe a new variable that you guys haven't seen before, or a variable type, uint8_t. This is an unsigned 8-bit integer. It can house any number or value from 0 to 255, which is magically kind of what the hues are. And because that's all it can house, once it hits 255, it'll cycle back to 0 for us. We're going to call it start hue because I think that's what we had at the bottom. And let's start it at 0, at the red color. Let's move the animation pretty quickly here. And then we're going to take our start hue and add 1 to it. Remember that plus plus. The start hue is going to start at 0 and divide the colors of the rainbow starting from 0 on the strip. Then it's going to add 1 to it. And so it's going to come back up here. This is going to be 1, which means that first pixel is going to be like off red. And then it's going to divide that along the strip. So you'll see the color of the strip is going to change because that very first pixel is going to cycle from red all the way up to violet and then back to red. And that's going to affect how the other colors are laid out on the strip. And they too will change. It's already on blue. Every 50 milliseconds, this starting color keeps increasing. And therefore, the delta that we created spreads across in a different way. Why don't we try 10? You get these undulations of colors going down the strip. why don't we animate the delta hue? I'll create a variable called delta hue. And why don't we define it up here? So uint 8_t delta hue. And why don't we start that at 0.2? Every go around, that first pixel is going to start at one hue higher, which causes the spread to be different. Why don't we also increase the spread every time? See what that looks like. Sometimes you got to play around. It's tough to sometimes envision what it'll look like. This looks like all glittery. And then there is a point where it flashes red real quick because both the delta hue and the starting hue are 0. And then it starts all over again. Just by using FastLED's basic functions, you can already create a lot of cool effects. I always have a constantly updated written tutorial on the website. Link for that will be below. And I invite you guys to join my community. Every week we have live events like these live workshops where you can interact in real time, as well as our community build sessions where we get together via Zoom, bust out our projects, get to that completion. Unlike a lot of the projects I got going on here, which are like half done. So yeah, they need a couple more community build sessions. So I had a great time tonight, guys. Bye.